In this video, we're going to answer some questions based on radians. So we'll be able, by the end, to convert from degrees into radians and from radians into degrees. So on question 1, page 137 of your textbook, we were asked to convert each of the following, all of these, from degrees into radians. From our learning, we should know that 180 degrees is equal to pi radians. Pi isn't anything different than usual, it's your normal 3.14, or you can just use your calculator and take it to as many decimal places as you like. So our key conversion is 180 degrees is equal to pi radians, so we can divide both sides by 180, and then 1 degree is pi over 180 radians. So from there we'll be able to multiply up and find out what any of those are. The first one is as straightforward as I can get. It is 180 degrees, which we learn off is pi radians, so that's 3.1459 and so on radians. Second one is 90 degrees. So again, from here we could just use our heads, and 90 is half of 180, so we're going to have pi over 2 as we can see. We'll just follow this stepwise, and this will give us a more general solution. So we again work out that 1 degree is pi over 180 radians, so 90 degrees, multiply both sides by 90, and then you will get this, which gives you pi over 2 radians. In the next one, we are working with 45 degrees. So again, we know that 1 degree is pi over 180. So 45 times that will give us 45 degrees. So multiply both sides by 45, and we end up with, when we cancel down, pi over 4. 30 degrees, again, the same method. Multiply both sides by 30, and we get pi over 6 radians. 60 degrees, from our basic conversion of 1 degree equals pi over 180. We multiply both sides by 60 to give us pi over 3. Both sides by 360 to give us 2 pi, which is our full circle, which is another one that we'll need to remember. 10 degrees, multiply both sides by 10, that gives us pi over 18 radians. I would be happy with leaving all of these in this form, pi over 18, rather than what it actually gives, because it's quite easy to write this accurately, whereas if you give it as a decimal, you're going to have to round off, and that'll lead in some rounding errors. So typically, if you can, just leave it as the fraction, and that's the most accurate way to leave it. Final one we have here is 48 degrees, and 48 degrees, again 1 degree, multiply both sides by 48, and we get 4 pi over 15, which is again a bit of an awkward fraction, and it gives us 0.26 recurring. That little dot on top is 2.26 recurring pi radians. You again could multiply that by pi, so you did 0.26 recurring by 3.14 and figure out what that is. I just didn't go that far, I left it in terms of pi. Then we have our second question, which deals with converting from radians into degrees. So we have all of these different conversions from radians, we need to put those into degrees. So again, our key conversion, if we remember, 180 degrees is equal to pi radians. We divide both sides by pi, so that pi over pi will give me 1 radian is equal to 180 over pi. So for the first one, we are looking for pi over 5. So we know that 1 radian is this. So 1 radian is 180 over pi. So then we multiply both sides by pi over 5. So 1 by pi over 5 is pi over 5, and 180 multiplied by pi over 5 is what it is in degrees. This is easy because we can cancel both pi's, so we get 180 over 5, which gives us 36. So pi over 5 radians is equal to 36 degrees. It's not particularly easy to do this in a calculator. You could check your work, but it's something you would need to be able to do in your head. Our second one, we need to calculate what pi over 7 radians is. So again, we know that 1 radian is 180 over pi. So then we multiply both sides by pi over 7. We can then cancel as before, so we get pi over 7 radians is equal to 180 over 7, which roughly gives me, rounded off, to 25.71 degrees. Then we have 1 radian. So what is 1 radian? It's pi over 180 over pi, and then here, just for something a bit different, I wrote it as the decimal. So that works out, like it said in the textbook, in the previous one, 57.3 degrees. 4.2 radians, so again, not as complicated in one way as pi over 7. We do the same thing, we know 1 radian is this, so you multiply both sides by 4.2, and again, throw it into your calculator, and you get this answer. And then finally, pi over 3, so multiply both sides by pi over 3. So pi over 3 radians is equal to 1 radian, 180 over pi, multiplied by pi over 3. They both cancel, we get 180 over 3, and that gives me 60 degrees. Then to finish off, similar thing for pi over 6. Again, pi over 6 is half of pi over 3, so you could work with your fractions there if you can spot them. So half of 60 is 30, but just follow it the same stepwise. Pi over 6 is equal to 180 pi times pi over 6, which gives me 30. They cancel, 180 over 6 gives me 30. And again, it's useful to remember 180 over pi is 1 radian, and then you can just multiply by whatever you need. In the third and final question then in the section, we're told the radius of a circle is 3 meters. What is the length of the arc of the circle subtending an angle of 1 radian, then pi radians, and then 45 degrees, and finally 120 degrees at the center of the circle? So this is a question that we could get where it's not a straight conversion, but we would need to convert depending on what unit we're using. They do often use some of these words like subtending. So the definition of subtend is to form an angle at a particular point when straight lines from its extremities are joined at that point. So what this basically means is you'll have an arc. So this is traced in the arc, and this would be the center. Then that doesn't naturally form an angle. So to form an angle, you need to subtend. So you need to go from the extremities, so the ends of the arc, and trace that back to the center. So what you get then is this shape here that's formed, and then this movement around this center, when you subtend, gives you this angle. It's again something you could gloss over and not pay particular attention to, but it is nice to know what it means as well. So that's the word subtending, and that is the one they use because, again, like everything in language, there's a specific word which has a specific meaning, and that's the most accurate one to use. So again, back to our question, we first off have the radius of the circle is 3 meters, and we need to know the length of the arc, so we're looking for the arc length S, first off with 1 radian. So by definition, 1 radian is the angle made at the center of the circle by an arc whose length is equal to the radius of the circle. So the angle in radians is equal to the arc length over the radius, so that is theta, which is our angle, is equal to our arc length S over our radius R. So we know for the first one, the radius of the circle is 3 meters. So to get 1 radian, we need to have an arc length of 3 meters. I didn't go into that any further. The second part of the question, they ask us when it's pi radians. So from this formula, theta is equal to S over R. We're trying to find S, so we multiply both sides by R. So we get R theta, or theta R, is equal to S. And that's the formula that we use. So arc length is equal to theta times R, or R theta will be what is a little bit easier to say. So my angle, which I'm told is pi radian, so I put that in. My radius is 3 meters, so I multiply that. So my arc length is 3 pi meters. You can forget about the radians. You wouldn't say radian meters. Radian is just for the measurement of the center, so you can ignore that for your answer. Arc length is measured in meters. Then the third part, again, they try to put in a new twist, so they ask us for 45 degrees. So we first need to convert 45 degrees to radians, and that's easier than any other thing we could do to try and get an answer. So we convert 45 degrees as before. It's pi over 180, which is 1 radian times 45, which gives us pi over 4. So back to this formula, the arc length S is equal to R theta, or theta R. So my theta is pi over 4 times my R, which is 3. So that would give me 3/4 pi. So again, 3 pi over 4 and then 3/4 pi. Throw it into the calculator and you get 2.36. So there are the calculations. Our final calculation in this section is 120 degrees. So again, rinse and repeat. First convert to radians. 1 degree is pi over 180. 120 degrees, multiply both sides. So we end up with 41 over 60 pi. You could write it as a decimal, but again, that's just an easy way to write it. S is equal to theta times R, which gives you 2.05 pi meters. Again, I wouldn't be too worried about what form you give it in. You could take this 2.05 times 3.14, but 2.05 pi is a fine answer as well. Our next question is question 4. So it tells us an arc of length 3 meters, so that's our S is 3 meters, of a circle subtends an angle of 3.5 radians. So we're given that there at the center of the circle. What is the radius of the circle? So again, our basic formula is theta is equal to S over R. So then R will be equal to S over theta. So you cross multiply, so S is equal to R theta as before, and then theta equals S over R. Sorry, R is equal to S over theta. So we know our information. S is 3 centimeters, theta is 3.5 radians. We have our formula, so we just substitute in, and then we can find our radius of 0.857 centimeters, because that's what our unit is for length. Question 5 again we have here. So the sun subtends an angle of 0.00932 radians to an observer on the Earth. If the sun is 93 million miles away, find the approximate diameter of the sun. So this is a more complicated question, so we'll need to use a diagram. So as this is an approximate solution, we assume the following. We have the observer, which is at the center. When they observe the sun would subtend that angle, so it'll be from top to bottom, so that is the angle you're looking at. That angle is given as theta, and again it's extremely small because the sun is so far away. So as it subtends here, our arc length will approximate to a diameter because it's a very slight curve. Theta is equal to S over R as before, so S is equal to R theta. We then know our radius because it's 93 by 10 to the 6 miles. So we're told that 93 million miles away. So we know that the radius, because the sun is 93 million miles away. So S is equal to our R by our theta, which gives us this answer. Again, we use miles, so we get miles, and this is an approximation, so we can work just like that. So again, it's an interesting thing that you can calculate the distance of the sun. Sorry, you can find the diameter of the sun if you know the distance just by the angle that is covered. Our final question is question 6. So it tells us a pendulum is 2.2 meters long and it oscillates or swings back and forth through an angle of 10 degrees. What is the length of the arc traced out? So again, definition, oscillates means to swing back and forth in a regular rhythm. So it's not just over, it's over and back. That's one oscillation. Half an oscillation, one oscillation. So that's oscillate. It's another important word in physics that we'll meet again. So it's going over and back, so that's the oscillation, and we need to figure out what length our arc is traced out. So when it's hanging, that will be the center of the circle that will be formed. So these lines here, this is kind of when we let go, and this is where it ends up. This is like our before and our after, our blue and our red. So our arc is traced out as it goes through there. So what information are we given to the question? A pendulum is 2.2 meters long, so that will be our radius. Our angle then is 10 degrees, so up here we're going to have an angle of 10 degrees. Again, we're trying to deal with radians, so we first off need to convert our 10 degrees into radians. 1 radian is pi over 180 times 10 gives us pi over 18 radians, should not be degrees. So our radius is 2.2 and we need to get our arc length. So theta is equal to S over R. S is equal to R by theta. R is 2.2 meters. Theta, as we have here, is pi over 18. So our arc length traced out is 0.384 meters. So that's all the kind of questions we have in this section. You should be able to do out all of those, and these will be the basics we'll need moving forward into circular motion.